Hello everyone, welcome to EEEE lecture number 42. So last time we have seen the 2 wattmeter method, power measurement for measuring power in a single phase AC circuit. So this was the general arrangement. These are the 2 wattmeters consisting of a current coil and a pressure coil, and it's connected to a star connected load, alright, with a 3 phase supply RYB. Okay, so what is this method was that in specifically speaking, the method was that the reading shown by the 2 wattmeters, if you add them together, that is W1 plus W2, that will be equal to the power formula for a single phase circuit, for a 3 phase circuit, which is root 3 VLIL cos phi. So that is what is indicating the active power of a 3 phase circuit, and which is equal to the reading of the 2 wattmeters W1 and W2 in addition of that. So that is what the concept is of a 2 wattmeter method. That is when we connect these 2 wattmeters over here, and the readings of the 2 wattmeter are W1 and W2. If you add them together, that will give you the true power of the circuit. All right. And in this process, we have developed some formulas of W1, that is RY, VRY into IR cos 30 plus phi. Then W2 is VBY IB into cos 30 minus phi. Phi is the phase angle. And in terms of line voltage, W1 is VLIL cos 30 plus phi. This will be used in one of the numericals. And W2 is VLIL cos 30 minus phi. Alright. That depends upon which is greater. So basically, the smaller the angle of phi, the greater the value of W is. So in this context, W2 is greater than W1, because if you add the angle phi, the cos of that angle will be greater. I mean lesser value. So this formula is important. W1 plus W2 is root 3 VLIL cos phi. And also one more thing was there, by doing the algebraic steps, we have also realized that the reactive power of the system is given by Q, which is root 3 times W2 minus W1, where W2 is greater than W1. And if we want to find the phase angle, considering that W2 is greater than W1, it is given by tan inverse of root 3 into W2 minus W1 upon W1 plus W2. Okay, so this is very important, that here the power factor is the leading power, lagging power factor. Power factor is cos phi. So these formulas are pretty important. Now in general, let's say for both lagging and leading power factor, your phase angle is given by tan inverse of square root of higher reading minus lower reading. Now what do you mean by higher reading? Higher reading of the wattmeter. Okay, we have 2 wattmeters, so the higher reading among the two will be the higher reading, and divided by higher reading plus lower reading. Now here, one more point to be noted is that the higher reading wattmeter will always be positive, whereas the lower reading wattmeter may be positive, may be negative. Okay, so just keep this thing in mind, and let's start solving the numerical for today. Okay, so this is lecture number 42. We are solving numerical number 48. We are into module, last part of the module for module number 3, that is AC circuits. So, in numerical number 48, 2 wattmeters are used to measure power in a 3 phased balanced load. Alright. Now, this 2 wattmeter method is valid for both star connected and delta connected load. Alright. So, we have to find the power factor if two readings are equal and opposite. Now, which readings of the 2 wattmeters? The two readings are equal and positive, and one wattmeter reaches 0. Alright. So, in the upper level thinking process, the phi is given by tan inverse of square root of W1 minus W2, considering that your W1 is greater than W2. Alright, this formula we know, and the power factor formula we know that it's cos phi. So basically we have to find the power factor for these three cases. Alright, so let's write it down now. For the first case scenario, what is the situation? So in the first case, two readings are equal and opposite. That means, let's say the 1 wattmeter is W1, alright, and the other wattmeter is equal to W2 but opposite. So that means they are equal but opposite, means W1 is equal to minus of W2. Alright, did you understand? So here this is case A, which is two readings are equal So W1 and W2 are equal in magnitude, but they are opposite. Alright. If this is, let's say, 1000 watts, this will be minus 1000 watts. Now we have to use this formula, phi equal to. So let's use it. Phi equal to tan inverse of square root of. Now we, from this formula, let's say W1 is greater than W2. So we substitute over here W1 minus W2. So here minus of minus W2 and divided by W1 plus W2. Here it is minus W2. So here it will be, okay. So here it will be minus W1. So denominator will be 0. Alright. So phi will be tan inverse of infinity. Now in such a case, your angle phi will be 90 degree, because tan 90 is not defined. So tan inverse of infinity will be, basically your angle will be 90 degrees. You can check it out in your calculator if you wish to. Alright. So in first case, angle is 90 degree because tan 90 is not defined. I can write the reason over here. If you type tan 90 in degrees in a calculator, it will be not defined. Alright. Now we have to find the power factor. So power factor is given by cos phi. So here it is cos of 90, and we know cos of 90 is basically 0. So that's the answer for the first case. The answer is power factor is 0. Alright. So for the second case, let's check the condition now. Two readings are equal and positive. That means, let's say, if W1 is the reading of the first wattmeter, it is equal to the second one and it is positive. Alright. So let's apply the formula now of phi. So phi is tan inverse of root 3, let's say W1 minus W2 upon W1 plus W2. So in this case, it will be tan inverse of root 3 times W1 minus W1 upon W1 plus W1. So this case, tan inverse of 0. This you are getting tan inverse of 0. And if you find out here in the calculator, your phi will be 0 degrees. Alright. So if the phi is 0 degrees, your power factor, which is cos phi, will be maximum, because cos 0 value is 1. Alright. So for the second case, this is the answer. The power factor is 1. Now in the third situation, they are saying 1 wattmeter reads 0. Alright. So let's consider that W2. There are 2 wattmeters, W1 and W2. So W2 is 0, let's say. Alright, and let's find out the value. So part C is saying, let's say W2 is 0. Say, out of W1 and W2, W2 is 0. So let's find out now. Phi is again tan inverse of root 3 root 3, we have W1 itself, okay, minus 0 upon W1 plus 0. Alright, so this W1 cancels and you will get tan inverse of root 3. And if you calculate in your calculator, your angle phi, we get tan inverse of, let me save this document once, tan inverse of root 3. So phi will be equal to 60 degree. You can check it out in your calculator. And for power factor will be, in this case, your power factor will be cos phi, which is equal to cos of 60 degree and that is coming out to be 0.5. Okay, so when one of the readings of the wattmeter is 0, your power factor is 0.5. All right. All right. So when the two readings are equal and opposite, the power factor was 0. When two readings are equal and positive, equal and opposite means W1 was equal to minus of W2. When two are equal and positive means W1 is equal to W2. And when one wattmeter reaches 0 means either W1 or W2 is 0. All right. So we can say either W2 is equal to 0. Alright, in this way, this was a simple numerical. You have to calculate phi and then the power factor, which is cos phi. Alright, I hope you have got similar answers to what has been shown over here. Okay, so let's move on to the next numerical. Numerical number 49 says that two wattmeters are connected. Whenever the word two wattmeters is used, immediately understand it's a numerical on two wattmeter method for power measurement. So two wattmeters are connected to measure power in a three-phase circuit using two wattmeter method, which indicate 1250 watts and 250 watts respectively. So whichever is the higher one, denote it as W1, and whichever is the lower one, we denote it as W2. Okay, the higher one will always be positive, the lower one can be positive or negative. So find the total power supplied. So they are asking us to find capital P and the power factor of the circuit. Okay, under these situations when both the readings are positive. All right, so this is the first situation when both the readings are positive. When the latter reading is obtained by reversing the connections of the pressure coil. So in first case we have to use W1 equal to positive of 1250 watts and W2 as plus 250 watts. So both the readings are positive. In the second case, they are saying that when the latter reading is obtained by reversing the connections of the pressure coil. That means they are saying that W1 is 1250 watts, but W2 is reversed, so that is it is 250 watt. Remember, the higher reading is always positive, the lower reading is can be positive or negative. So this is the scenarios. So for W1 equal to W1 and W2 equal to positive values for first case, you have to find the total power supplied and the power factor. And in second case, when W2 is minus 250 watts, you have to calculate the same. Alright, so let's start with the first case. Our thinking will be same over here, that phi is tan inverse of square root of higher reading minus lower reading divided by higher reading plus lower reading of wattmeters. Alright, and power factor is cos phi. Alright, so let's start. So for the first case we have W1, both readings are positive, means what? The power will be W1 plus W2. So that will be how much? 1250 plus 250. Okay, watts. So the total power will be 1500 watts. Alright, so total power supplied is very easy to calculate. Next is we have to calculate the power factor. So for that we have to calculate the phase angle. So phi. Alright, let's say that W1 is the higher one and W2 is the lower reading. So let me write the formula now. Tan inverse of square root of W1 minus W2 the whole divided by W1 plus W2. In our case, W1 is 1250, W2 is 250. So let's calculate now further. So phi is given by tan inverse of root 3 into 1 to this value, let me write it over here. This is 1250, this is 250. And W1 plus W2 is already, it's actually 1500. That's not what we have seen earlier over here, right? So the answer will be 1250 minus 250 is 1000, and this will be 1500. Alright, so this, if you solve it further, get this over here 2 and 3. So angle phi will be tan inverse of 2 by root 3. So angle phi will be coming out to be 49.1 degree. Alright. So in this case your power factor will be cos phi, that is cos of 49.1, that will come out to be 0.655. Alright. So this is the power factor for the case 1, that is both the readings are positive. Now let's go to the second case where W1 is 1250 but W2 is minus 250 watts. Alright. So here it's the B case. So W1 is 1250 watts and W2 is minus 250 watts. So first of all, the total power supplied will be by the two wattmeters will be W1 plus W2. That will be 1250 minus 250. So that comes out to be 1000 watts. Alright. Next we have to find out phi, which is tan inverse of square root of W1 plus W1 minus W2 divided by W1 plus, sorry for that, W1 plus W2. Alright. So this will be tan inverse of root 3 into, so this is 1250, this is minus 250. Okay. This is 1250, this is minus 250. So 1250 minus of minus 1250 will be 1500. So it will be 1500 divided by, this will be 1250 minus 250 will be 1000. So if you calculate it further, it will be 3, 5 3s are 5. Yeah, that's it. So it will be tan inverse of root 3 root 3 by 2, and that if we calculate it, the angle will be 68.94 degrees. Alright, and subsequently the power factor will be cos of this angle, so it will be cos phi, which is cos of 68.94, which comes out to be 0.359. Alright, so this is the power factor for both the cases. Okay, so let's halt for a few seconds so that you can write it down and verify the answers on your own. So are the cases clear to you? I hope so. And the calculations are supposed to be matching. Alright. Okay, done. So we'll move on to numerical number 50. The power measured in a three-phase circuit is measured by 2 wattmeter. If the total power is given as 50 kilowatt and the power factor is given, which is 0.6 lagging, you have to find the reading of each wattmeter. Okay, so basically we have to find W1 and W2. Alright, they are asking us to find W1 comma W2 equal to question mark. Alright, total power is given to us and the power factor is given to you. Alright, so let's start finding the solution. So power is by the 2 wattmeter meter is given by W1 plus W2, and that is 50 kilowatt, that is 50 into 10 raised to 3 watts. Let's call this equation number 1, and in second case power factor is given to you. Alright, Power factor is given by cos of phi, which is given equal to 0.6, and that is lagging. So phi will be cos inverse of 0.6, and that will come out to be 53.13 degree. Alright, so phi we have calculated, and we have the total power. So now formula for phi will be tan inverse of root 3 W1 minus W2, the whole divided by W1 plus W2. Alright, so this can be written as tan theta also. I mean, I can write this as a tan phi also, no problem at all. So tan phi is equal to this. Alright, so that means, yeah, and one more thing we can do is, yeah, so tan of 53.13 degree into W1 plus W2 is equal to root 3 times, let me rephrase it, root 3 times W1 minus W2. Alright, and W1 plus W2 is already, we have got it as around how much? 50 kilowatts. Alright, so from here, if you want to calculate W1 minus W2, it will come out to be tan of 53.13 degrees into 50 kilowatt divided by root 3. So W1 minus W2, if you calculate in your calculators, it will be 38.49 kilowatts. Alright, we can call this as equation number 2. Okay, but individually what is originally needs to be found out? We have to find the reading of the each wattmeter. That means we have to find out W1 and W2. Okay, not W1 plus W2 or W1 minus W2. So from equation number 1 we got W1 plus W2. From equation number 2 we got W1 minus W2. So what we can do next is, we can say equation 1 plus 2. So that will give us, see, let me write it first. W1 minus W2 is 38.49 kilowatts. So if you add them together, what are we getting? Your W2 gets cancelled, and we get 2W1 is 88.49 kilowatt. So this gives us the value of W1 as 44.245 kilowatts. So that's the answer. Now once we get the value of W1, we can easily calculate the value of W2. So W2 will be 50 kilowatt minus W1. That will be 50 minus 44. That will be 5.75 kilowatt. Alright, 5.75 kilowatt. So that is the answer. And this completes the numerical. We have got the reading of 2 wattmeters, that is W1 and W2. So we are moving towards solving the last numerical for today. That is numerical number 51. Alright, so let's read it. Each phase of a 3-phase delta connected load has an impedance of Z phase equal to 50 angle 60 degrees ohms. The line voltage is 400 volt. Calculate the total power. right? So it's a three-phase circuit. We have to calculate the total power. What will be the reading of two wattmeter connected to measure the power? So we have to also find the value of W1 and W2, reading of the two wattmeters. Okay, we have solved this three-phase numerical before. Your impedance of each leg is given to you. So thinking process is delta connected load. So for a delta connected load, phase and line voltage are same, and phase voltage is given by phase current is given by phase voltage divided by impedance of that phase. Line voltage is given by root 3 times phase voltage. Power is given by root 3 VLIL cos phi, and the reading of the two wattmeters W1 and W2 is given by VLIL cos 30 degree minus phi and VLIL cos 30 degree plus phi. Okay, provided W1 is greater than W2. Alright, so let's start with a numerical. So we'll first write down the given data. According to the given data, we have the following. Z phase is given to you 50 angle 60 degree ohms. So as per the standard form, this is actually Z phase magnitude. Okay, normally if we want to write this, this is in the form of a polar form, right? So from here, this is Z phase and this is angle phi. Okay, and this is a leading, it's a positive, right? So it's a leading angle. Alright, so since it is also given that line voltage is 400, that is VL is 400 volt, and it's a delta connected load. So we'll write over here delta connected load. Alright, now let's start solving it. In first case, for a delta connected load, the phase voltage and the line voltage are one and the same. So phase voltage is equal to line voltage is equal to 400 volt. Second case, if we know the phase voltage, we can calculate the phase current. So phase current is given by V phase upon Z phase, the magnitude only. So 400 divided by 50, and that will be 8 amperes. Then next is the line current. IL will be in a delta connected load. IL is root 3 times phase current. So that will be root 3 times phase current is 8 amperes. So this will be 13.86. You can cross check it with your calculator. Then next is the total power consumed. So the power is given by in a three phase circuit will be root 3 VL IL cos phi. Alright, so we can write power is equal to root 3, VL is 400, IL is 13.36 into cos phi. So phi is basically 60, so cos of 60 degree. Alright, so this if you calculate in your calculator, it will give you 4.8 into 10 raised to 3 watts. That is same as 4.8 kilowatt. Alright. Now next, it is also mentioned that after you calculate the total power, what will be the reading of two wattmeters connected to measure the power? So we know the formula for the W1 and W2, considering W1 is greater than W2, so we can say the reading of two wattmeters will be given by. So let's write it down. W1 will be VL IL, considering W1 is greater than W2. So VL IL cos of 30 degree minus phi, and W2 will be VL IL cos of 30 degree plus phi. So this VL is around 400, IL is 13.86 into cos of phi is 60. So cos of minus 30 will be around same only. So this value will be around 4.8 kilowatt. You can cross check this answer. Then next will be 400 into 13.86 into cos of 30 plus 60. That will be cos 90, and cos 90 is 0. Alright. So the reading of the two wattmeters are 4.8 kilowatts and 0. So one wattmeter is reading around 4.8 kilowatts, other is reading it 0. So as we can see that the total power measured in a 2 wattmeter method will be given by W1 plus W2, and that is same as 4.8 kilowatts. Alright. So this answer seems to be correct. Alright. So this comes to an end of your numericals for power measurement using 2 wattmeter methods. Now one more numerical is there, which I'll give you for homework. So in this, I'll give you the hints. The reading of the two wattmeters connected to measure the two power in a three-phase star-connected load 400 volt system are 3000 and 5000 watts. So find the power factor, total power and line current. So in this, we first have to calculate phi, angle phi, which is tan inverse of square root of W2 minus W1 upon W2 plus W1, considering that W2 is greater. So over here, this is W2, this is W1. So W2 is greater than W1. Alright. So I'll give you a hint, I'll not solve this. Power factor, once you find the angle phi, power factor will be cos phi. Alright. And then the total power will be W1 plus W2. And the line current will be given by, once we know the power, once we know the line voltage, cos phi we know it, then we can easily find the line current from it. Alright. So in this way, we can easily find the value of the active power. So let's do it very quickly. So the given data is VL is 400 volts, W1 is 3000 watts, W2 is 5000 watts. So let's first calculate phi. Phi is tan inverse of, now in this case W2 is greater than W1, so we'll write the formula accordingly. It will be W2 minus W1 divided by W2 plus W1. Alright, so substitute the values over here. So phi will be given by tan inverse of square root of 5000 minus 3000 divided by 5000 over here plus 3000. Let me save this document. So it will be basically 2000 divided by 8000, which will give us the answer as, I'm directly writing the answer. So phi will be tan inverse of square root of 2000 divided by 8000. That will give us directly 1 by 4. So root 3 by 4. So tan inverse of root 3 by 4 will give phi as around 23.41 degrees. Alright. So once we got this, we can easily find the power factor. The power factor will be cos phi, which will be cos of 23.41 degrees, which is 0.9177. Alright, so this is the power factor. Next is the total power. In a 2 wattmeter method, total power is the reading of the 2 wattmeters addition of the reading of the two wattmeters, that is 5000 plus 3000. So that will give us 8000 watts. So pretty easy. Next we have to calculate the line current. So active power is given by root 3 VL IL cos phi. Alright. So from here everything is known. P is known to you, VL is known to you. So IL will be given by P upon root 3 VL. Cos phi is nothing but power factor itself. So power is 8000 divided by root 3. VL is given as 400 and power factor is 0.9177. Just we have calculated. So if you put all the values in the calculator, you should get somewhere around 12.58 amperes. Alright. So the value of the line current will be 12.58 amperes. Alright. In this way we can calculate similar numericals. Now let's see if we have one more. That's the end of it. Yeah, it's the homework numerical. Exactly similar. So over here the 2 wattmeter readings are 3000 watts and minus 1000 watts. Okay. So in this case it is 3000 and minus 1000. So we can follow a similar approach. Here I've given you the answers. Total input power factor, it's 0.2773, and power factor itself, total input power will be around 2000. That will be very straightforward. Here let me add it as 3000. Okay, 3000 plus minus 1000, that will be 2000. And the line current we can calculate by the similar procedure. Okay, so yeah, that is all from this lecture. We have solved around 4 numericals on 2 wattmeter method for power measurement. Next time we'll start with the next module, that is module number 4 on electrical machines, and the first topic will be transformer. Alright, so that's it for today. Thank you all for joining.